This is the IoT for All Media Network. Hello, friends in IoT. Welcome to Let's Connect, the newest podcast in the IoT for All Media Network. I am Ken Briota, Editorial Director for IoT for All, and your host. If you enjoy this episode, please remember to like, subscribe, rate, review, and comment on all your favorite podcasting platforms. And to keep up with all the IoT insights you need, visit iotforall.com. Before we get into our episode, the IoT market will surpass $1 trillion in the next few years. Is your business ready to capitalize on this new and growing trend? Use Leverage's powerful IoT solutions development platform to efficiently create turnkey IoT products that you can white label and resell under your own brand. Help your customers increase operational efficiency, improve customer experience, or even unlock new revenue streams with IoT. To learn more, go to iotchangeseverything.com. That's iotchangeseverything.com. Now, let's connect. My guest today is from Federated Wireless, Kurt Schonbach. I may have totally mispronounced your name. I'm positive I did because I'm a bad host and forgot to ask you before we got started. So, Kurt, I apologize. Kurt is CTO of Federated Wireless and has 25 years of wireless experience, plays a key role in developing new technologies and business strategies, and is creating all of the stuff that we're using to connect all of our things to the internet. I do that backwards? I think that worked. Kurt, welcome to the show.
Great. Thanks, Ken. And you're a terrific host. You did a wonderful job. My name is Kurt Schonbach. It's nice to be here with you today. As you said, I've been the CTO for Federated now for 6 years. Federated's a company that has helped create this new way of accessing spectrum. A new shared spectrum paradigm, and something called the CBRS, or Citizens Broadband Radio Service, which is a really beachfront property in terms of spectrum for connectivity solutions and for IoT. So it's been really exciting to be part of creating this new ecosystem that is going to bring all sorts of new connectivity solutions to the market, really help, I think, energize connectivity for the enterprise. And, I'm thrilled to talk to you about what we're doing in sort of the IoT space around connectivity.
Yeah, and I want to dive into that. But first, before we get there, if you don't mind, could you just sort of give us a short explanation of CBRS? I'm sure there's folks out there listening that aren't familiar with it yet. And I know when I first heard the term, my first thought was my grandfather's ham radio, W1WKW, was his call sign. And I know it's different than that. So for folks who don't have my ancient references to refer to, what is CBRS?
You bet. CBRS is a shared spectrum band. And what's unique about CBRS is that we use the power of cloud technology to organize and manage the band. So the concept of spectrum sharing has been around for a long time. In fact, unlicensed bands, Wi-Fi, uses a form of shared spectrum. But in that case, we rely on the radio technology itself to figure out how to coordinate with users. So if multiple users of, Wi-Fi are in a given area, something called a listen before talk protocol is used for each of the radios, and they sort of organize themselves in a very ad hoc way. What we've done in CBRS is create a lot more value by using much more efficient methods, actual, software algorithms, to figure out the best way to assign spectrum to different users. And that model creates a tremendous amount of flexibility. We're able to do both licensed and unlicensed uses. We can manage interference, so we can provide much more deterministic access to spectrum than has otherwise been possible. The other just quick thing to note about CBRS is it's a lot of spectrum. It's 150 megahertz of spectrum. And to give you sort of a frame of reference, if you look at, say, Verizon or AT&T or T-Mobile, and you take away their real high-frequency millimeter wave holdings that they're using for things like fixed wireless, and just look at the spectrum that they only use for their mobile network, in any given geography, they have about 150 megahertz of spectrum. So this is like taking the amount of spectrum that Verizon uses to serve, 100 million customers, and put it in the hands of the enterprise to do all sorts of, really amazing things.
Yeah, and that sort of leads us into the first phase of what I think we both want to talk about, which is connectivity in general in IoT. If you want to find a more diverse and potentially complicated space than platforms, just go look at connectivity. And there's so many different options, so many different things that do what they do very well in almost every case, but are often, I think, single use or very focused use options. If we're talking about satellite's really, really good at what it does in terms of connectivity, but like it has some drawbacks like battery life and expense and everything else. But if that's your option, you're out in the middle of the ocean, that's your option.
Right.
Zigbee and Z-Wave, really great for certain smart home applications, but you probably don't want to use them for your car, say. So let's talk about some of the applications of connectivity that are best used in industrial IoT, because I know that's sort of home base for Federated, although you probably play pretty much everywhere. Let's start with the industrial side, because that's where a lot of the enterprise folks are really operating. Everyone's concerned with supply chain connectivity right now for lots of reasons. And so what are some of the connectivity options that folks should be looking at there?
Sure. So Ken, you made a great point, and I just want to circle back to that here briefly, which is about the need for or power of ecosystems when it comes to adoption of new technology. And I think that's what we've seen has been sort of an inhibitor of IoT applications to date, is that a lot of proprietary wireless technologies, a lot of technologies that maybe really don't have a big ecosystem associated with them in terms of equipment and devices, the ability to embed connectivity into other things like sensors or cameras or other things. We're seeing all that change. With CBRS, the other really important thing that we've been able to do in CBRS, and we will continue to see in the future, is the fact that we've created this massive ecosystem of equipment, of end user device options, of modules, embedded capabilities, and that's really going to drive sort of the adoption of the IoT capability in all sorts of different market segments. You're right, sort of the industrial the IoT sort of space itself is probably the one that is leading the charge right now. There's, a tremendous need for connectivity in automation, whether it's a factory or a warehouse or, a large industrial facility. And the reason why I think we're seeing such a sort of a big pull in the industrial space right now is because a lot of the applications that they're running around automation, leveraging things like, early forms of AI or other machine learning capabilities, require, very high velocity of data, require, secure private networks. You're controlling potentially $1 million pieces of equipment on a factory floor. You want to make sure that you've got a really stable, reliable, secure connection.
Well, right, that you are the one controlling that multi-million-dollar piece of equipment.
Exactly. You don't necessarily want to rely on a carrier to provide that service. That wireless capability. And, Wi-Fi, frankly, scares you a little bit because that Wi-Fi sometimes, the bandwidth is unreliable, the connection drops out, you lose coverage. So that's why we're seeing this sort of, really ideal application for CBRS. 5G in the enterprise is, around sort of these industrial applications. And I'll draw your attention to one project that we're doing.
Wait, before you get to that project, I want to explore one other thing and then definitely this project. So in a factory or warehouse or other sort of industrial setup, it seems to me that there are a couple of different ways to accomplish connectivity. There's the pretty traditional, everything is connected via often Wi-Fi to a gateway, and then that gateway is your door to the outside internet. There's the new wave of edge architectures that are probably giving each one of those devices some measure of limited connectivity to a cloud that then is the gateway to the outside world. And then there's sort of direct connectivity where each of the machines maybe has its own SIM card, cellular chip, whatever. And to me, that sort of bypasses the internal gateway entirely and maybe even never gets to the outside internet. Maybe it just stays within the internal cloud server or whatever, but is not getting there via some other mechanism. And do you think that's a fair outline of the very high level, broadest connectivity styles in this kind of environment? Or am I missing something, or have I overstated the way
that was perfect? And in fact, to sort of build on that concept, there are, some obvious pros and cons with each solution, whether it's Wi-Fi sort of in a private network, like you said, or the direct connect method that you described, which is where, say, a mobile network operator is bringing their service indoors, and each device is, running over sort of that macro, consumer network. Each of these, have sort of different pros and cons. One thing that we've seen sort of the sweet spot for connectivity, this connectivity as a service offering that we provide, the use of CBRS shared spectrum and 5G sort of falls in the three areas of, one, coverage. You really want very reliable coverage, deterministic access to spectrum, to control. And control means that it's a private network. Control can also mean that you're trying to achieve a degree of data sovereignty. So that's sort of that architecture that you were talking about, where you have an edge platform, edge compute platform that's maybe running applications. You're keeping data locally. It's not traversing the public network. And you can use your own IT staff to deploy, maintain, operate it. And the third piece is cost. So if you've got a large geography that you need to cover indoors, Wi-Fi doesn't really scale well for that. If it's a big factory floor or even if it's a campus, Wi-Fi, becomes really challenged when you're trying to, do, both indoor and outdoor coverage and things like that. And here again, CBRS really sort of excels at, providing that, ideal cost point or, the return on investment that you need for these smaller deployments that are indoors and larger deployments that include indoor and outdoor.
So let's get into this project that you guys have been working on with, it's a smart warehouse project, if I remember
That's
correctly, right?
It's one of many that we're doing in the connectivity area for IoT, but this one's really exciting because I think this will be the template by which 5G and shared spectrum find its way to, the commercial sector and the enterprise broadly. So we were awarded through a DoD R&D contract vehicle, a large project with that we're executing on as the prime. Federated Wireless is leading this, along with a couple of other partners who are providing equipment and other software capabilities to build a complete smart warehouse solution for the U.S. Army in a base based out of Albany, Georgia. This project, I think, like I said, is really unique because it's using full 5G. It's actually integrating in concepts like Open RAN to keep costs of the 5G infrastructure very low and make the solution very scalable for enterprise deployments. And we're going to be testing out a whole bunch of applications from autonomous forklifts to equipment and material logistics from when it arrives at the dock or bay all the way through the warehouse to actual forward deployment with the troops themselves. These applications, I think, are really the same sort of applications that any factory, warehouse, other industrial user needs to take advantage of. Like I said, I think this project with the DoD is really exciting because this smart warehouse will be a blueprint that we can follow for all sorts of future deployments as we expand out into the commercial sector.
I want to touch on a couple of the things you said there that I thought were interesting, but the first is when you say DoD, you mean Department of Defense,
right.
Correct?
Yep.
And I assume that means that they're fairly concerned with security and network infrastructure, and they've probably got some people looking into that sort of thing. So that's just an endorsement in and of itself on the network security and fidelity of the technology, I would assume.
Security and fidelity, exactly. Those are two key things for the DoD as they're looking at this initiative, is they are making direct investment in trying to build a 5G ecosystem so that they can take advantage of, commercial R&D and effectively take off-the-shelf technology that they harden and add the other security features that they need to make sure this meets, the level of requirements that the DoD would have for, for security. So they see this as a completely different platform than, say, Wi-Fi. And that's why they're making this R&D investment in terms of trying to stimulate this capability for the DoD and ultimately for the commercial sector. You think about, where did GPS come from? Every smartphone that we have has GPS. That was a DoD technology that ultimately found an enormous commercial application. This is sort of the same thing that I think we're going to see with 5G.
The piece of 5G that I am still skeptical about, that I have yet to have anyone convince me on, is the infrastructure. It is, although an extension of existing cellular bandwidth, it is a whole new type of infrastructure that you need, as I understand it. You need different repeaters. You need more frequent ones. You need a bunch of other things. And all of that, to me, just keeps ringing up that register. And especially, we're not talking about like national 5G networks and things like that, which are a whole nother layer of thing. But in a private 5G environment, like it seems like you're talking about generally, that has to also become a factor, is cost. And you said at the same time, you're being conservative about cost. So I'd like to know how you're achieving that, especially with a client like DoD where, and I don't like to get political, but I think this is bipartisan, they don't care how much something costs.
Well, they do ultimately. Part of the reason why they're investing here is that they do want to get out of the business of buying very specialized proprietary technology because it's expensive. Here's the big thing that's changed, and shared spectrum is part of this big revolution that's occurred. But I think the key thing to see here is that with 5G, and especially this focus now on opening up new market segments like bringing 5G into the enterprise, we've really broadened the scope of equipment suppliers that are able to build product for the market. And also, there's been a global effort to develop Open RAN technology, which drives down cost. So if you look at what happened in the data center world, in order to get, routers and switches and other things down to price points that could sustain, or support the growth of the data center, companies invested in developing very, neutral hardware solutions that could be contract manufactured and a software stack that runs on top of it. The same thing's happening in the wireless world with 5G, where now the radio technology is becoming very disaggregated. You can buy the equipment from a global contract manufacturer at very low cost and then run a separate software stack on top of it. And that sort of a disaggregation of hardware and software has opened up all sorts of new opportunities for smaller, more competitively priced options to come into the market. This is no longer the market where only the big global, vendors who sell to, telecoms are providing equipment. Now, companies that traditionally built, Wi-Fi gear could now get into the 5G market as well. So I think that's, Ken, where you're going to see this, big change in terms of affordability of infrastructure for the enterprise. The other thing that shared spectrum specifically does, and what CBRS does, is it creates a guaranteed market opportunity. It's spectrum that anyone can use. So it's not like you have to wait for a big order from a mobile network operator to come in and say, I'll now build equipment with this profile of 5G to support, your nationwide deployment. As an equipment supplier, I can begin building this technology because I know a market exists, whether it's mobile network operators or cable operators or, big IoT SIs to, end user device makers. All of them are going to want to be in this business because the common denominator here is the access to a spectrum band that, they know will be available, will be, suitable for these IoT applications in the enterprise.
That's actually really reassuring to hear that I had hoped that sort of with scale and with technological innovation, these costs would start to come down. So that's good to hear that that's starting to happen. The other thing I want to ask about, and this I think is most relevant to like manufacturing environments and warehouse environments, is 5G's often lamented trouble with penetration on walls and surfaces and stuff. Is that something that CBR struggles with too? Is that just not true anymore? Was it ever true? I'm no technological expert. I'll be the first to admit. That's why I have you here.
Okay. Well, let me break it down. So a lot of the early 5G that people have heard about and, this sort of early 5G, where some of the service providers started deploying 5G specifically for fixed wireless, to, for example, provide a high-speed broadband connection to, a residential user. That 5G, if you will, is 5G that operates in a very high portion of the radio spectrum called the millimeter wave. So this is a portion of the band where there's a huge abundance of spectrum, but the physics associated with propagation of those radio waves means that it doesn't go well around corners, it doesn't go through walls very well. It really only works in sort of a line of sight, environment. So that's high band, what we call millimeter wave. Where we are for CBRS, it's what's called mid-band. This actually is a band that sits right between the two Wi-Fi bands in terms of its sort of, address in the, in the radio spectrum. And, you can think about it as having performance that is similar to what Wi-Fi can do today, which, we know Wi-Fi does penetrate walls. Wi-Fi goes indoors and outdoors. It has a lot more power, 50 times the amount of power that you can operate with versus Wi-Fi. So, what we're going to see is much better coverage indoors. And in fact, something that will work really well in harsh environments, like where there's a lot of, like a warehouse or a factory or things where, it's a very challenging environment from an RF perspective.
And it can carry the same kind of data load as Wi-Fi and everything. I mean, it's not one of those super limited LTE-M kind of deals where we're dealing with data.
That's right. This will be gigabit speeds at for the enterprise using 5G. So it will be able to support literally all of the applications that they need to. I would conceive that they need to do, and because of the way 5G operates, it's suitable for fixed uses, sort of nomadic uses, persistent and itinerant uses, and fully mobile uses. So you could have the same network supporting all of these IoT applications, and providing connectivity to your employees, to say tablets or barcode scanners or other things that they maybe have on their belt and they're carrying around with them.
So now I'm torn. I'm torn because I have two things that I want to talk about, but either one easily eats up all the time we have left. So I'm going to totally abdicate my responsibility and make you choose. Would you like to talk about sort of the implementation process sort of in the field if you were putting in a CBRS network, or would you rather have a fight about Wi-Fi 6 versus 5G? It's totally up to you. I think the listeners are here for either one, and we'll just do the other one in a sequel.
Well, let's do the sequel, please. I'll take you up on the offer, and we'll save maybe the topic that has more controversy associated with it, the Wi-Fi 6 versus 5G debate, maybe for part two. I'd like to just maybe quickly focus on what does it take to deploy this, because that is, I think, like you said, a key question that those who are starting to investigate shared spectrum and 5G, immediately start to ask is, one, can I afford it? And two, how hard is this to actually, deploy and implement? And I think the other good news, in terms of the implementation needs, is that the industry overall is doing a lot of work to really simplify this and make 5G very IT friendly. Federated's playing a key role in that. The work that we're doing with something we call connectivity as a service is to, provide a turnkey capability so that if you want an IoT network on 5G for your enterprise, we can come in and do it all for you. We'll act as that systems integrator. Big hyperscalers and, other cloud providers are getting into this business. We're partnering with folks like AWS and Microsoft Azure to bring applications with a connectivity solution to their marketplaces. So you could literally go online and, after a couple of clicks, be able to procure not just maybe an IoT application, but a network, devices, integration needed to be able to, for someone to come in and deploy and operate that on your behalf. So things are getting a lot easier. That I think over the course of this year through 21, we're going to see much more work being done to simplify deployments, make them much easier for enterprises to wrap their arms around, to get comfortable with, so that ultimately deploying 5G in the enterprise should look no more complex. In fact, maybe even less complex than what it takes to deploy Wi-Fi today, which, pretty much everyone's comfortable with. No one really, worries too much about that.
I mean, I've got a mesh network in my house now, and that was pretty easy. So, I figure if I could do it, how hard can it be? Unfortunately, Kurt, that is just about all the time we have. I am going to put a bunch of links in the show notes for you folks out there listening, so you can find out more about Federated Wireless and about Kurt Schaubuck and all of the work that they're doing over there. Kurt, thank you so much for being my guest. This has been a great discussion. I really appreciate it.
Thank you. It's been my pleasure.
The pleasure's been entirely mine and my listeners, I'm sure. Thanks again to all of you listening out there. I hope you've enjoyed our discussion, and if you have, please make sure you like and subscribe so you don't miss out on any of our episodes. We post every week, and I hope you'll leave us a rating, review, and comment on your favorite podcasting platform. If you'd like to suggest a guest, please click on the link in the description. And we also have a great sister podcast on our network called the IoT for All podcast, so make sure you check that out.
Hey Ken, let me jump in real quick and introduce your audience to another awesome show on the IoT for All Media Network, the show that started it all, the IoT for All podcast. podcast, where I bring on experts from around the world to showcase successful digital transformation across industries. We talk about use cases and IoT solutions available in the market and provide an opportunity for those companies to share advice to help the world better understand and adopt IoT. So if you're out there listening and haven't checked it out, be sure to go check out the IoT for All podcast, available everywhere.
Thank you, Ryan. Now get back to your show. And thank you all for joining us on this episode of Let's Connect. I've been Ken Briota, Editorial Director of IoT for All, and your host. Our music is Sneaking on September by Otis McDonald. And this has been a production of the IoT for All Media Network. Take care of yourselves. You are listening to the IoT for All Media Network.